Good morning, everyone, or good afternoon, rather, and welcome to day two of ACI's fall virtual seminar. Today, we're bringing you a presentation titled Low Carbon Future for the Cement and Concrete Industry. To any of you joining yesterday, who joined yesterday, thanks again for being here today. Today, we have two fantastic presenters, Auer and Bart Kanters. Just a brief intro to both our presenters before we get started. Adam has over 20 years experience as a sustainability professional working with public, private, and nonprofit institutions. As Vice President of Environment and Sustainability with the Cement Association of Canada, Adam works with government, industry, environmental, and other civil society groups to promote, enhance concrete's contributions to sustainability, with a specific emphasis on life cycle approaches to climate change mitigation and adaptation. Prior to joining the CAC in 2012, Adam managed Environment Canada's Corporate Environmental Innovation Initiative, a multi-stakeholder program to promote the business and financial case for corporate environmental leadership and the link between sustainability and an innovative and competitive economy. Adam holds a Master's of Environmental Studies from York University and a Bachelor of Science in Ecology from the University of BC. Our second presenter, you might recognize Bart Kanters. Bart joined the RMCAO in 1999 and has progressed from technical engineer to engineering manager to his current role as president of Concrete Ontario. Prior to joining Concrete Ontario, Bart was a division manager of a concrete restoration company in the Kitchener-Waterloo area. Bart's experience with ready-mix concrete is as a civil engineer with the responsibility of addressing the technical concerns of both Ontario concrete industry and the local design community. He has a Bachelor of Applied Science degree from the University of Waterloo, an MBA from Heriot-Watt University in Scotland, and is a registered engineer with the Professional Engineers of Ontario. And now I think I'll hand it over to Adam.
Great, thanks very much, Danny, and good afternoon, everyone. Thanks for having me here again this year. Some of you might remember I presented last year, and so I'm going to do a bit of a recap of some of the stuff that I talked about last year, in particular focused on embodied carbon, sort of the high level pathway to carbon reductions in the cement and concrete industry, and some of the work that we had been doing with the National Research Council and other Government of Canada departments on life cycle assessment and procurement policy. But really I want to focus on what's new this year, in particular a dramatically increased sense of urgency around all things climate change. I think a realization that whether you're a cement producer or a concrete producer, you are now firmly on the radar of those concerned about decarbonizing our economy, and talk a little bit about some of the moves that governments are making to address that impact the cement and concrete sector. And then finally, just walk briefly through what, as an industry, we've been doing collectively to respond to this challenge, both in terms of establishing a climate ambition for the sector, but also technological and policy roadmaps to achieve that ambition. So very briefly, just sort of recapping some of the slides that some of you may have seen before. A big driver for the attention on concrete, I should say that climate change has for many years been focused on industrial emissions. So the cement industry, as a large industrial emitter, has been deeply involved in conversations around carbon pricing and other policies. But that focus on emissions is now shifting in a way that is really bringing concrete into the conversation, and a lot of that is driven by this notion of embodied carbon that comes from the green building sector, and that really refers to all the carbon that's emitted from the extraction and manufacture of products. So in the case of concrete, cement is where most of the emissions come from, but ultimately concrete is the product that gets used in buildings and infrastructure. And as the construction industry, architects, developers, and others start to look at reducing carbon from their projects, they're no longer just looking at, say, the energy emissions from their building. They're starting to think about the materials they're using to build those structures as well. And one of the reasons is that when you look at buildings in particular, they're about 40% of global emissions, but of those emissions, about 25% of those of that 40% come from the materials that we use in the construction process. So it's a a significant chunk of the pie. And the other reason is because, sort of anticipating a bit of the conversation around urgency, there's this notion that in buildings and infrastructure, when you emit carbon to build the materials for that project, those emissions are coming immediately, whereas some of the operational emissions from heating and cooling your building, for example, accumulate over time. So you get more early bang for your buck by dealing with those embodied or so-called upfront emissions. And cement and concrete, obviously huge players in terms of construction materials. In fact, the most used construction material on the planet is concrete. I'm sure you're all familiar with the stat that nothing is used in greater volume on the planet than concrete except for water. So, it's not surprising that we would be on the radar screen. But just from the industrial perspective, you can see here that when we look at industrial emissions only, cement is a significant part of that pie. About almost a third of all industrial emissions come from cement manufacturing. That translates into pretty significant numbers. Almost 7% of global emissions, total human caused emissions, come from cement manufacturing. In Canada, it's a bit less than that. It's about 1.5%, but it's still close to 11 megatons, and so it's significant. And I think people realize that you can't possibly address the climate challenge without addressing emissions from cement manufacturing. But on the concrete side, you can see when we look at actual projects, materials are what drive the emissions of in this case is an example of a multi-story office building, and of the materials, it's concrete, and in particular the cement in that concrete, that is the major player. So that basically explains why concrete is suddenly becoming a big focus of those concerned with climate change. Here's just an example, a Canadian example of Canada Green Building Council sort of further developing the LEED programming and creating a separate sort of carbon-focused standard called the Zero Carbon Building Initiative, and embodied carbon is very much part of that standard. So it's becoming a very normal thing, certainly in the green building community. Up until now, we've been talking about the different things that we're doing as a sector to decarbonize that final sort of concrete product. A lot of it focused on the cement side, so improving the efficiency of the manufacture of cement, blending lower carbon cements like Portland limestone cement, using lower carbon fuels in our industrial processes. But increasingly, we've had to talk about the concrete side too. So, looking at mineralization technologies that are starting to come out about injecting CO2 or putting carbonated materials into the concrete itself. And then, oops, sorry, I got some animations here. And then also talking to the design community about what role they have in making sure that they're optimizing their concrete, that they're aware of and using the low carbon solutions, that they're taking advantage of some of the design based strategies to reduce carbon over the life cycle of their project. 2021, many of us might think of it as the year or almost the second year of COVID, but in many ways it was also the year of climate change. Just a couple of reminders of some of the events of this year. We had massive climate-driven catastrophes in developed nations, which I think is maybe part of what was unique about 2021. We had massive flooding in Germany, people dying, houses being washed away, massive destruction, just sort of unthinkable in the recent past in a place like Germany. In Canada, of course, we had the heat dome and heat deaths out west, and massive fires and impacts on many communities in that province. And just a general, this is all sort of aligned with the message now that we're hearing internationally around the urgency of climate change, in particular in the lead up to the upcoming COP26 meeting. The IPCC issued its most recent report, which was effectively branded a code red warning for humanity. So I think the sense of urgency is palpably higher, and you can also see it reflected in recent polls of people's attitudes to climate change, there has been a dramatic upswing in support for and expectations around more aggressive climate policy. In terms of what that means for us in particular, I think good and bad. There's lots of work that's been happening outside our industry to think about what decarbonization of both cement production and concrete looks like. I think some of these reports have been helpful and useful, but of course there's a risk that now we have some outside stakeholders that are starting to shape the narrative about what climate change means for our sector and what kind of investments and strategies need to be deployed. And so we're, seeing some of this already in policy in Canada and the US. Just before last Christmas, Government of Canada updated their climate plan, which had for the first time a very specific focus on heavy industry, including cement. Some of that is about ambition and stringency around their existing climate policies like carbon pricing, but also a huge amount of potential funding support and technology support for hard to abate sectors like cement. There's an $8 billion net zero accelerator fund available for heavy industry to tap into some of the more expensive and potentially more impactful technologies that need to be deployed more quickly. But we're also seeing some attention to the government's role in supporting low carbon technologies. And I know Bart will talk a little bit about some of the work that's happening in this space, but effectively the federal government in Canada is now looking at mandating lower carbon cements. This is actually, I need to update this, they're not mandating PLC, but there will be a reduction in the carbon intensity of any concrete used for federal projects. They're also mandating disclosure, so all concrete used in federal projects will require an EPD, and the requirements around both the carbon intensity reduction and the disclosure are going to get more stringent over time. And cement and concrete are the first materials to be considered under this Greening of Government program, and they will be the first to have actual requirements imposed on them. And then, this is the same thing in the US. There was a Biden summit not too many months ago. One of the areas of collaboration between Canada and the US was an agreement to start collaborating on greening of government using procurement to drive low carbon solutions into the market. And there again, concrete and steel are the primary targets out of the gate. And we've already seen in the United States a number of state level procurement, low carbon procurement policies that target cement and concrete, and also a conversation happening through the UN, where Canada and the US are both major players in driving that conversation. And here's just a couple of examples. I mentioned there's already some procurement policies in place. You can see that concrete is one of the major focuses. But the risk is, some of the approaches that are being considered without a whole lot of collaboration with or input from our sector. And you can see, very prescriptive solutions, limiting cement content in concrete rather than letting concrete producers and cement manufacturers work together to provide the lowest carbon innovations available for the types of projects that the concrete is being used for. So that's sort of one of the things that we are, while certainly on a global scale, I think the industry has shown a lot of leadership, proactive leadership on climate. We really need to get ahead of some of the initiatives that are happening kind of unilaterally outside of our sector to make sure that, we're driving the types of policy and other solutions to make sure that they bring, that they offer us the most flexibility and the most room for innovation in this space. And so that's really, in a nutshell, I think that's really the reason why the industry has started to become very proactive in making sure that stakeholders understand that we take climate change seriously, that we have science-based driven ambition around reducing our carbon emissions, and that we have an actual plan to get there, and an understanding of what we need in terms of government policy and other supports in order to realize the ambition, which is ultimately the ambition to get to net zero concrete. And so in the US, you may have seen that the Portland Cement Association released a roadmap earlier this month. It was part of a broader sort of global effort led by the Global Cement and Concrete Association towards developing a global response for cement and concrete to the climate change challenge. And so also earlier this month, they released their plan, which is called Concrete Future. And it is their roadmap to achieving their climate ambition, which was released about, I think, 6 or 8 months ago, committing the industry to aspiring to net zero concrete by 2050. And then this roadmap also articulates, the level of ambition for 2030, 40, and 50 as sort of milestones to get to that net zero space. I'm not going to go into all of the different details, but just to give you a snapshot of what it looks like. You can see, I didn't copy the whole ambition here, but the meat of it is, we will deliver society with net zero carbon concrete by 2050. And to do that, we're going to work across the built environment value chain and think about things not just in linear terms, but in circular terms and from a life cycle perspective. From the nuts and bolts in terms of how it's structured, we're looking at what we call the 5 C's. So what can we do in clinker production? What can we do in cement production? And what can we do with concrete? What kind of reduction opportunities are there if we partner with the construction sector? And we're also looking at carbonation. So now that there are better tools to measure the level of carbon uptake by existing concrete infrastructure, that's also being considered in the roadmap. But the important part is that it's not just a commitment to applying technologies in each of these different phases. It's also an articulation of assumptions, basically, around what kind of support we will get from construction stakeholders and from governments in order to achieve the level of ambition that we think is possible in each of these areas. So it could be, attracting financing for technology investment and R&D. It could be a migration away from some of the prescriptive approaches to specifications to a more performance-based codes and standards process that invites low carbon innovation. It could be, a leveler playing field around transparency and disclosure, making sure that the data that's being used for decision making is up to date and accurate and reflective of the full life cycle benefits of cement and concrete products, and then supporting policies, including and maybe especially low carbon procurement policies at the federal, provincial, and municipal level. To give you a sense of how it all breaks out, this is what the global roadmap looks like. So you can see that they have charted a business as usual case. So they're anticipating growing demand for concrete products between 2020 and 2050, and then how they, through various levers, they are going to address the carbon emissions associated with that demand through looking at that 5C structure. So, reducing some of that concrete demand by being more efficient in its use in design and construction, efficiencies in the actual concrete production process, savings from the cement used in concrete, savings from how the clinker used to make cement is produced, decarbonization of some of our what they call scope 2 emissions. So, transportation infrastructure emissions that come from infrastructure outside our sector. And then you can see that recarbonation piece is significant, but the most significant piece is carbon capture, utilization, and storage, which is a key technology to reaching net zero and more or less needed to deal with the chemical process emissions that happen in clinker production at cement facilities. This gives you just a little bit more detail on what each of those levers actually mean. So you can see from savings from clinker production, for example, we're talking about thermal efficiency, using decarbonated raw materials in the kiln, advanced low carbon fuels like hydrogen, biomass, that sort of thing. You can see when it comes to efficiency in concrete production, we're talking about optimizing mix design, optimizing the constituents of concrete. Because it's a global roadmap, they're also taking into account developing countries that have, that still use a lot of bagged cement. So they're talking about industrializing some of that concrete manufacturing process in those regions. And I won't go through all of the details here, but you can see on the slide that there's a whole bunch of different factors in each of these decarbonization wedges that have been considered and ascribed sort of a numerical value of what we think we can achieve in terms of carbon reductions using each of these different levers. Just very briefly, here in Canada, we are in the process of developing a Canada-specific roadmap that is aligned with what the GCCA has done, as well as, by extension, what the PCA has done in the US, but tailored to the Canadian policy context, which is certainly more advanced in Canada than the United States. You know, we already have a commitment to $170 per ton carbon price by 2030. We have the $8 billion Net Zero Accelerator Fund and a sort of ecosystem of climate policies and ambition already in place. And so part of that has been actual formal agreement with our sector. So recently, the Cement Association of Canada launched a partnership with the Government of Canada to support the development of our roadmap, and more importantly, to start talking about the different policy, financing, codes and standards, and other levers that our government is going to have to move on if they are going to support us in realizing our ambition. So this is like a very significant and positive development for our sector, and the work of that partnership is sort of unfolding in parallel to our own inwardly focused roadmap development process. So we have all the pieces in place, I think, for success here. And then I thought I would just end my presentation with a little video that we've produced to kind of build some excitement about the release of our roadmap. So if you'll just bear with me for 2 seconds while I try and figure out the technology. It's just I think a 30-second video. I gotta press play. Great, so I'm going to stop sharing my screen now, and thanks very much for your attention. And I'm going to pass it over to my colleague, Bart.
Thanks, Adam. Appreciate it. I'm just going to get this set up. Okay.
While you're getting set up, I'll just note that I was 25 minutes on the nose.
That was perfect timing. You might have to make me the presenter. It's not letting me share my screen right now. Or I'll make myself the presenter. There we go.
Just did it, Bart.
Thank you. Perfect. So thank you for that. It's tough to follow a very powerful video like that, but we're going to continue on. So jumping back to what Adam was talking about, we'll get down to the nuts and bolts on the concrete side. So again, looking at the various cross sections when it comes to ready-mix concrete, we've got our standard raw materials. Well, cement makes up that 7 to 15% of the volume of the concrete. Again, as it sits right now, it has a fairly big carbon impact. That's obviously going to reduce over time as we move along, but that's one of the key things that we have to address. The Cement Association and the Canadian Ready Mix Concrete Association, as Adam highlighted, have been working with the federal government on different ideas when it comes to green concrete procurement. We're still waiting for final documents to be produced. But again, there's been lots of discussions about how can we utilize things like Portland limestone cement? How do we set relative targets for reductions? And really what it all comes back to, as Adam highlighted, is if you're going to improve something, you have to start measuring it. You can't possibly improve it until you start measuring it. So really what the cement and concrete industry has done is we've made a commitment. We're happy to be the guinea pigs and go first from the material standpoint and try and participate actively in quantification exercises to look at what our current carbon contents are and how we can optimize them, because we know we've got a lot of options out there for reductions. So how did we do this? Back in 2016, the Canadian Ready Mix Concrete Association started off with our first industry average EPD for ready mix concrete. So we went through and 18 different mix designs. We basically looked at, for a sample mix design with different levels of either GU or GUL cement and varying levels of supplementary cementing materials, what is the impact that has on the carbon content of the material? So picking an example here, this is just 25 MPa concrete pulled out of the existing document. You see the lowest carbon content is at 214 kgs per cubic meter, and the highest is at 327. So what's the worst? Not a big surprise when you use just GU cement and no supplementary cementing materials. So the first number that you see in that table, that gives you the highest carbon content. If we switch over to GUL, we immediately get an 8 to 10% reduction right off the bat. And then as we move through and start using different supplementary cementing materials, you get better and better impacts. So this was our first attempt to try and address or quantify what our carbon contents were across the industry. We're a very technical industry, so as soon as we start doing a national average, that creates a whole bunch of technical challenges for us, because the aggregates in each province vary, the cements in each province vary, the site conditions in each province vary. So doing a national average is a little challenging. So we're going to come back and talk a little bit more about that. So trying to get down to the nuts and bolts, what can we do? So a number of key factors that were highlighted. So we've got to look at things like the design, optimizing the design, optimizing construction methods. Construction schedule is one of the key things I'm going to come back to. So ready mix concrete is different than every other construction material. The reason that it's the most used material in the world is it's so versatile. When you order a 2x4, it's a 2x4. The carbon content of that 2x4 is fixed. If I order a 2x6, its carbon content is fixed. It's slightly higher than the 2x4. Go to a 2x8, 2x12, very linear. With ready mix concrete, we're supplying a plastic product out to the job site that can set in as little as 5 hours to as long as 3 days. And strength specifications can be as short as 24 hours for form removal, or 56 or 90 days for mass elements that where thermal conditions are a consideration. So there's a huge amount of variability in our material. So when it comes to these discussions, simple tables really don't work. We have to start working with first the contractors, because they're the people that are directly placing the material, and secondly the designers when it comes to how can we optimize these mixes, what impacts to some of the changes they're going to make have. So now I'm going to get myself in trouble with this slide in a couple ways. I'll start off with the most obvious one for me, is that from a concrete association standpoint, we never, ever show mixed proportions, ever. So I've broken a fundamental rule. I'll see whether I'm still employed by the end of the day, but I'm only bringing it up this one time, just one time, to talk about where these numbers come from. So when it comes to environmental product declarations, what we're looking at is, when it comes to ready mix concrete, what are the various factors at the concrete plant that impact the various indicators for the product category rules. So we've got 6 different indicators. Global warming potential is the primary one that people are focusing on, but we've got 5 others. And so it's things like how much natural gas did we use in the winter to run boilers? How much electricity did we need to run the motors at the concrete plant? How much diesel fuel did we use to run the trucks to both mix the material and drive out to the job site? All of those things have an impact on our carbon content. Add to that then the raw materials and you get the whole picture. So as we were talking about before, again, cement and concrete, maybe looking at the top picture, which is another dangerous thing that I have here. A lot of people see us as being a little old, a little inefficient. But again, there are lots of performance options that are out there to make us lean, mean fighting machines. And that's really what we're going to go through and talk about. So stepping back and looking at the mixed proportions, let's just say this was a hypothetical 30 or 35 MPa concrete. It doesn't matter because I'll never show you proportions again. But when we look at where are the impacts to try and help people understand where we're coming from, cement, as was indicated before, currently is a fairly big contributor. There's going to be changes to improve that, but that's where we sit right now. So if we break down and we look at the raw materials that we're using, cement is the biggest impact. In this example, using the 2016 data from the Canadian Ready Mix Concrete Association, we've broken the carbon impacts out by raw material, but this cement component is the cement plus all of the plant inputs like the diesel fuel for the truck, natural gas for winter heating, all that kind of things piled in. So basically, as you walk through this table and you look at it, you see cement is the primary factor when it comes to global warming potential and CO2. So it's one of the key things that we need to optimize for. When it comes to slag, in this example, we've got 70 kgs of slag, but it's only having 2 kgs of carbon input. Why is that? Again, trying to understand slag is a waste product from the steel industry. So the initial slag production in itself has a carbon intensity, but because it's a waste product from the steel industry, that carbon is initially proportioned to the steel industry. What we add is when we have to collect it, we have to grind it, and we have to transport it back to the concrete plant in order to use it in concrete. So it's not zero, but it does have an impact, but it's significantly less than cement. And that's why a lot of the strategies that you see focus around supplementary cementing materials as being a really big, a huge impact for its quantity when it comes to carbon reduction. Sand and stone still make up 65 to 75% of the material. They have impacts as well. You still have crushing for limestone, you have washing, screening, processing at the aggregate facilities. Those all have impacts. They have to be accounted. Even water. We're either pumping water out of the ground in rural plants or we're using municipal water. It had to be treated. It had to be pumped out to the concrete facility. Those all have impacts. So these are the rough numbers that we're talking about when we get into it. So now we go back and we say, how can I reduce these impacts? So thinking about those numbers, which you're never going to remember ever again going forward, we look at what's one of the biggest impacts. So cement content is of GU or GUL. GUL is lower and better, but cement content is one of the big things. So one of the things that we constantly see is people specify, for example, 30 MPa or 35 MPa concrete, and what does the test report show? 45 or 50, drastically over-designed. So one of the critical issues that we have to address is the over-design that we have in our mixes just to avoid some of the challenges out on the job site. So again, working positively with other associations like the Canadian Council of Independent Laboratories, we need to encourage proper and efficient testing practices out on job sites. If there's challenges for the testers when it comes to providing or obtaining proper cylinder storage conditions, we need to work with them to address that. If we're going to optimize our mix designs, and that's one of the key components that Adam pointed out in his net zero roadmap, we need to reduce the over design in concrete. That needs to be one of the primary things that we look at. Secondly, there's also opportunities here for new technologies. Again, when it comes to maturity calculations and some of the new technologies and sensors that are out there, they're not new to the construction industry. Their use is expanding significantly, but that's the kind of technology that we need to go to. We need to be able to, if you want to start using higher levels of supplementary cementing materials, for example, in cold winter months, we need to know, work with the contractor and know what the actual strength in the field actually is, so that we're not impacting construction schedules. So again, there's new technologies out there, there's new companies that are actively pushing that. There's a lot of opportunities here, but again, it relates back to, we need to get accurate data in a timely manner where we can make adjustments to the mix designs to try and optimize the concrete going through. Other key component, we've been talking about Portland limestone cement here in Ontario for about 10 years now. Usage is very significant now. I think we're one of the leaders when it comes to the country in use of Portland limestone cement. But we won't get into the cement chemistry here, but basically we've got an elevated amount of limestone in the cement. The cement is processed at the cement plant to a finer particle size that makes it more reactive. We get the exact same concrete performance when it comes to strength development, air entrainment, freeze-thaw, permeability, freeze-thaw resistance, permeability reduction with this material for a 10% carbon reduction. So again, for the concrete industry, it's basically a one-to-one replacement. Whatever your GU content was, you're going to replace it with GUL and see that 8 to 10% carbon reduction right off the bat. So there's a lot of opportunities there. Supplementary cementing materials, we talked about those before when I showed that table with various impacts broken out by materials. You saw the impact of using supplementary cementing materials. We've been promoting supplementary cementing materials for 50 years. They have a lot of positive impacts when it comes to reduced permeability, increased durability, increased compressive strength. There's a lot of other reasons why we want to use these materials, but they also have the added benefit of being a much lower intensity when it comes to carbon. So expanding their use, really has a huge impact. And we're seeing, again, projects, mass concrete placements, for example, getting SCM replacement levels as high as 70% is not unheard of. So again, there's going to be more opportunities there. Another key component, one of the raw materials that I didn't show in the table when we were breaking out carbon impacts was admixtures. Did I do that because I hate admixtures and they're not important? Absolutely not. It's their carbon impact is so minuscule, it doesn't even meet the reporting thresholds. But saying that, admixtures are going to play and do play a critical role when it comes to concrete mix design optimization. So again, they have the ability to drastically change to the positive the performance properties of both the plastic and hard concrete. There's new materials out there that allow for cement optimization and have significant impacts on long-term durability. So there's a lot of new specialty materials out there that we can start using on projects. And again, we're seeing more and more expanded use there. They're going to play a big role going forward. Other critical factors, again, we get into some of the things that we want to avoid. We don't see very many minimum cement content requirements anymore in Ontario, thank God. But again, those are some of the challenges. We do see concerns regarding limitations of supplementary cementing materials. So again, there are some critical raw materials that are important to our ability to reduce the carbon intensity of the final product. And we want to start using materials that can still provide the historic long-term performance that concrete is associated with when it comes to strength and durability, but we don't want to be limiting the producer's ability to use these types of new and innovative materials. So where we're at right now, we've been working in partnership with the National Research Council, both the Cement Association and the Canadian Ready Mix Concrete Association over the last couple of years. We're very pleased that we've just recently kicked off a new environmental product declaration program. So we're looking at, instead of doing a national average, we are breaking the ready mix industry down into the 7 provincial regions that are represented by the concrete associations that are members of CRMCA. And what that's going to do is allow us to utilize the raw material data from each province or region to come up with accurate numbers. If we're going to start moving to a model where people are going to start evaluating concrete and its impacts when it comes to life cycle cost analysis, then we need to have accurate data, and averaging mixed designs between Vancouver, which never sees snow, and Northern Ontario doesn't make a lot of sense from a technical standpoint. So we're very pleased to see the support that we're getting from the federal government when it comes to having more accurate and representative data sets. So, for example, what we're looking at here in Ontario, this has been updated at a recent meeting earlier this week, so I haven't updated this slide. But again, we're looking at, for Ontario, what are the basic mix designs that we used. In the last CRMCA industry average project, we started at 25 MPa. And the reason for that is Western Canada has sulfates in the soil, and they can't use 15 and 20 MPa concrete for footings and foundation walls. But Ontario, we don't have that issue. We use a significant amount of 15 and 20 MPa in the residential and low-rise construction sector. So for Ontario, we're going to have 15 and 20 MPa options. We're also looking at some specialty options like SEC and other things, but we'll come back to that. In the previous edition of this document as well, we had to combine different supplementary cementing materials, but they're not all available in every region. In Ontario, slag is the primary supplementary cementing material that we use. So we're just going to look at generating tables that relate to slag and not fly ash. So different options that we're able to provide there. So really what we're looking at is how can we significantly improve the data sets that we're supplying out to industry. And I think we're going to see that. So Q2 of 2022, we're going to have that data available. We're currently in the collection process across the country when it comes to ready-mix plants. There's over 1,000 ready-mix plants in the entire country. So we're taking basically 30% of those and conducting surveys of what's the total amount of natural gas, what's the total amount of electricity, what's the total amount of diesel fuel that you used. We're going off the baseline of full year data, so it's going to be 2020 data that we're using at the concrete plant level. And then we're going to create updated tables. The other thing that we're going to do is trying to address some of the concerns that we're getting from both architects and engineers when it comes to, if we want to talk hypothetically about possible reductions that we can implement, how do we address that? Now, here in the Ontario marketplace, we do have some concrete producers that have facility-specific EPDs that are available for use. We'll see more as we go forward here. But really what we're looking at with this association-sponsored project is we want to at least have the ability for producers in Ontario to calculate their basic carbon impacts of the mixed designs that they're typically using. Then you can sit down with both the contractor and the owner and talk about where are the applications that we can try and optimize these mixed designs for carbon. Like again, we're not used to talking about optimizing for carbon. It's clearly going to be just as critical as compressive strength, permeability, early strength development when it comes to construction projects going forward. We're also partnering with the Cement Association and the Global Cement and Concrete Alliance when it comes to tools. So again, you'll see specifications going forward where there will be requirements for type 3, which is third-party facility-specific verified EPDs. And as I said, we do have members in Ontario that can offer those types of services right now. So stepping back and having a look at the performance side, what do we have to do here? So step one is embrace performance specifications. So again, we have projects out there where the owner sets performance goals and then immediately identifies a whole bunch of materials that you can't use. That's a critical issue, or sets artificial limits on how much of those materials you can use. So that's a critical issue that we're going to have to address as an industry when it comes to reducing our carbon content. So I think we're going to see a lot of work on that. Second thing, you have to start measuring it if you want to improve it. So I think we're going to start seeing more carbon reduction goals in specifications. That creates some new and unique challenges for us because, again, it is a plastic product. The general contractor has early strength requirements. Those early strength requirements typically can have a negative impact on the carbon intensity of the product. So there's applications where carbon reduction opportunities might be quite small, but then there's other applications like raft slabs or mass concrete placements where the carbon reduction opportunities are massive. So again, we want to look at how we can address that. We want to lower the use of, we want to start using lower carbon raw materials. So again, Adam talked about the cement industry and the things that they're doing to try and address the challenges there. You're going to see that in some of the other critical raw materials going forward. Again, there's talk of using, for example, recycled aggregates and what positive impacts could they have when it comes to the concrete. Again, aggregates are a relatively small component of the mix today, but going forward, as the cement industry reduces their intensity, the aggregate still makes up 70% of the concrete. So we're going to have to look for opportunities there. We talked about chemical admixtures as providing great opportunities as well. We need to look at that. Again, ensuring proper quality assurance, quality control. If we're going to optimize as an industry, we can't over-design intentionally going forward. If this is going to be one of the key goals, we need to optimize. In order to do that, we need to have proper testing. We need support from the general contractor out on the job site. We need to look at new and innovative technical systems when it comes to evaluating concrete properties in real time out on the job site. There's lots of new opportunities out there. And then the last one, which is probably one of the big picture challenges we have, is how can we adopt and start to utilize both new and innovative materials and evaluation methods. So again, there's going to be a huge focus on carbon reduction in the next 5 to 15 years, and there's going to be new and innovative materials coming out. One of our existing challenges comes back to codes and standards, and when it takes 15 years to basically move a new product through the code cycle, that's one of the big challenges that we're going to have to address as an industry if we're going to try and get ahead of the demands for carbon reduction that we're seeing out there. So that said, that brings me to the end of my presentation. Now I have to look. I was pretty close to 25 minutes as well, Adam. So take that, as the saying goes. So with that said, I'll welcome Adam back, and we're happy to address any questions that people might have.
I'll just step in and thank you both for presenting today. That was great. I have one question here. I'm not sure if you guys, who wants to take a stab at this. In addition to higher percentage SCMs and switching to Portland limestone cement, are you aware of, or are there any other innovative materials being used or tested locally to reduce carbon?
Adam, I'll let you go first.
Yeah, I mean, I can think of some, those are still the main strategies, I think. But for example, there's a company called Carbon Upcycling that carbonates the SCMs for an additional carbon benefit. And then Bart, I think, would probably know more about novel admixtures and whatnot that are being developed in some cases to, I think, allow for increase of traditional supplementing materials, but while maintaining strength and other characteristics. But a lot of the carbon reduction innovations, me being in the cement sector specifically, are coming from the cement manufacturing process. That's where a lot of the big levers are.
Yeah, at the ready mix level, again, we have 70 associate members, so I'm not going to name individual companies, but we definitely have some associate members that provide raw materials that can directly address those challenges, and a lot of coverage placed on them too. So there's definitely opportunities out there. Reach out to your concrete producer about that.
Thank you very much. Well, let me just see one more here. You guys aren't off the hook yet. Okay, how significantly does the increased processing required for high early cements impact the carbon footprint, and are high early plus lime cements on the horizon? That was a long one if you need me to repeat it.
This must be a precast related question. It's skirting on the edge of my engineering knowledge, but I can say that yes, there are conversations happening around high early limestone. And in terms of the impact on the carbon emissions, again, that's a calculation around, I understand sometimes high early or higher strength concretes in general allow you to use more cement, but less concrete overall. And so you kind of have to do a calculation to figure out whether that trade-off nets you a carbon reduction. But that's probably as far as I can go without starting to things that I don't really have knowledge about.
Yeah, and I probably shouldn't offer comment on it, but obviously in the precast operations, you've got a more controlled facility, as they like to point out. You've got also the advantages in some instances of elevated temperature curing conditions, which again lead to opportunities for optimizations either at the cement plant or even at the concrete production facility. I think that's one of the key things that we see in the ready mix industry is because we have the ability to blend so many different materials out on the job site, there's opportunities for optimization there. So if I went, for example, on the ready mix side, we see high performance concrete with silica fume being specified, typically 8% silica fume replacement. But when it comes to performance-based specifications, there's opportunities on the ready mix side. We don't have to use 100% SF blended cement. We can put in 100 kgs of that along with 100 Ks of GUL. So you don't wind up with an overall 8% silica fume. It's 4% or 3% or 2%. I think there's a lot of opportunities when you give the reins back to the concrete producer, whether it's ready mix or precast, to look at. We still need to hit these strength development timelines, whether it's on the job site or in the precast plant. But how can we optimize the mix to still give you all the performance you're looking for, but try and optimize now for carbon? That's really our challenges as producers. How can we optimize for carbon reduction? And you don't want to close any doors to that.
Thanks, guys. Someone's asking if we'll be able to find, first of all, they said great presentation. Can we find it available online? I believe we will be making recordings of these, and those will be on our ACI Ontario YouTube channel. So stay tuned for that. And last question, this is an interesting one, guys. One of our attendees today is actually making a slag fly ash geopolymer with no Portland cement. Are you able to provide any advice on how they can get funding to develop this further?
Yeah, I mean, there are traditional pools of funding through the National Research Council of Canada, SDTC, which should be looked at for sure. The other area which is not really developed yet is the low carbon economy fund that has traditionally been funded through Environment Canada in partnership with NRCan. It had a bunch of calls for proposals over the past several years, but it hasn't been really renewed yet. So, I would say my first instinct would be to talk to NRC and the folks at SDTC. There is actually a research program that the NRC is hosting in collaboration with the Cement Association of Canada, looking at a variety of different R&D needs across a few different decarbonization areas, and novel SCMs is one of them. So that would be another thing to get plugged into as well.
Yeah, and feel free to reach out to us offline. Again, this will sound a little more specific than we could probably answer here.
All right, well, thanks for those responses, guys. That is it for questions. Thanks to everyone for joining today, day 2 of our fall seminar. Hopefully you can join us tomorrow at the same time for our third and last presentation this week. Tomorrow we'll be presenting updating Canadian concrete standards to avoid slab rejection. Bart and Adam, thanks again, and everybody have a great day. Take care.
Bye now.